Dear students, Salam Alaikum. Today we shall go in detail on topic 10 Integration by Reduction Formulae in MATH200 Calculus 2. See, the word reduction means to make small in size. Something is smaller or less in amount, in degree or size. Now, the reduction formulae in mathematics helps you to simplify the problems where possible. And sometimes not possible, but in many situations it is possible to simplify and we'll do it. One example of a reduction formula is integration x power n e power ax. It is 1 over a x power n e over e power ax minus n by a x power n minus 1 exponential ax. Now look, you started with x power n and you ended up going to x power n minus 1. We have done questions for power 3, 2, 1 and even 0. So if you start with power 3, it will go to power 2, then in the next stage power 1 and then power 0, which you know how to do it. Now there are different ways to write the reduction formulae. One of them is to write in integral x power n e power ax. The same thing can be written as I of n, and sometimes we take the a this side and write it like an equation. We'll see different ways of writing in different questions if necessary, but most of the time we'll write it as it is given in the form here. Now in this topic we'll derive similar integration formulae for other cases, mostly using integration by parts, and sometimes we'll use some other technique from trigonometric identities. And once we have derived them, we'll learn how to apply them to a given situation. Now, these are the table of integration formulae. The first one is integration of x power n e power ax, which we have seen before. It reduces by 1. N goes to n minus 1. This is outside integration, so it really doesn't matter what is here. The main thing is here in the reduction formulae, one integral goes to the other and n reduces by 1. Ln ax whole power n, again it will reduce by 1. Then x power n sin ax will reduce by n minus 2. So if you start with power 3, you'll be left with power 1, which is much simpler. You start with power 2, you'll get 2 minus 2, which is power 0. So that's it. So, and again, most trigonometric functions, the power reduces by 2 because of the trigonometric identities. Now, these are the examples. We'll be deriving all of them, all 8 of them, and using all 8 of them. Now 7 and 8 will not use integration by parts, we'll use another technique which is easier than integration by parts. Now in most of these, if n is a natural number, then the process will stop after n plus 1 terms, at most n plus 1 terms. In sine, cosine, trigonometric functions, it will stop before that because the jump is by 2. If n is a fraction, then the process will never stop. If n is negative, it will never stop. In those cases, we use some other techniques and not this. Now, there are 8 derivations. Derive the reduction formula for integral x power n e power ax dx. Now, what we did in integration by parts, we put, when n was 2 or 3, we put u equal to x power 2 or 3. So here we'll try u equal to x power n. We'll get du equal to n x power n minus 1 dx. Now, what the remaining thing? dv equal to e power ax dx. This can be integrated v equal to 1 over a e power ax. Now apply the integration by parts. Integral u dv equal to uv minus integral v du. Now u equal to x power n and v equal to 1 over a e power ax. Now this v is coming outside and inside. Outside there is no problem. It is algebra. You write 1 over a first, then x power n, then e power ax. Now here you open this bracket, 1 over a will come out, n will also come out, you will get minus n by a. This minus is from the rule of integration by parts, and the derivative du is n x power n minus 1. So you have reduced from x power n to x power n minus 1 in this way. So this is the derivation of the reduction formula for this integral. Now in the last step, after you have finished all the integrations at the constant of integration. Now what rule of integration we are using here? E power kx, which is 1 over a e power kx plus c. Now you can verify whether the reduction formula is correct. Now this is your capital F of x is 1 over a x power n. Whatever comes on the right here is your capital F. Now capital F is 1 over a x power n e power ax minus n by a x power n minus 1 e power ax. When you differentiate this you will be differentiating by using the product rule, and here the integral will disappear and you will just write minus n by a x power n minus 1 e power. Now you differentiate this, 1 by a is outside, derivative of the first function into second function plus first function into derivative of the second function. Now the derivative of the first function is n into x power n minus 1. The derivative of the second function is a e power ax. Open this bracket. Two terms will cancel out. First term and the third term. You will be left with the, this a will cancel here. This a and this a will cancel. You will be left with x power n e power ax. You will be left with the middle term. After cancelling the a, you will get x power n e power ax. So all the reduction formulae which we are going to use can be derived and can also be verified. Now let's look at the second reduction formula, which is ln ax power n. Now here this appears to be only one function. So you put u equal to the function and dv equal to 1 dx. There is a 1 sitting here which we do not write. So we have done this integration of ln x and we took dv equal to 1 dx. So v equal to x and du equal to n bracket n power n minus 1 1 over x dx, and in the bracket you have ln ax. Now use your integration formula. By integration by parts formula you will get u into dv. Dv is x. I have written a dot here for multiplication. V du. V is equal to x and du equal to this quantity which we copied here. The x will cancel with 1 over x and this n will come out. You will be left with x ln ax whole power n minus n times the integral ln ax power n minus 1. So you have reduced from n to n power n minus 1. If you start with power 5, it will become 4, then 3, then 2, then 1, then 0, and your integration will be over. You can again differentiate and check it. Will not go much into differentiation right now. You can check it as a homework. Now the next thing is x power n integral sine ax. Now when we had to integrate x sine ax, what did we do? We took u equal to x. When we had to integrate x power x square sine ax, we took u equal to x square. Logically, we'll take u equal to x power n, du equal to n into x power n minus 1 dx. Now dv equal to sine ax dx. When you integrate, you will get v equal to minus 1 over a. This minus is important, 1 over a cos ax. Now use the integration formula, put the things together, you will get x power n into bracket minus 1 over a cos ax minus integral v du. So this is the v and the du is n x power n minus 1 dx. Now this minus 1 by a and n will come out. You will get minus 1 by a x power n cos ax plus n by a integral x power n minus 1 cos ax. Now we have to do it one more time. This time we will put u equal to x power n minus 1 and v equal to cos ax and integrate again by parts one more time. See, yes, our integral is x power n sine ax. All of a sudden we have cos ax here. This cosine after one more integration will become sine. So we do one more integration by parts. and finally we'll get minus 1 over a x power n cos ax plus n by a square x power n minus 1 sin ax. Now we have integrated. Now we have differentiated twice. First time we differentiated x power n, second time we differentiated x power n minus 1. So you have x power n minus 2 with the sign here, and there are some numbers which is n into n minus 1 over a square. So your reduction formula jumps from n to n minus 2. So all your sine cosine functions in general will reduce by a factor of 2. And the second integration by parts is shown over here, and you can again check the differentiation. You will get back x power n sine ax. Now the reduction formula for x power n cos ax is derived in a similar manner, so we will not go into much detail. You just note down the final formula. Again you will be integrating by 2 times. First time when you integrate by parts, that cosine will become sine with some numbers outside, and the reduction will be from n to n minus 1. Then again you integrate one more time, sine ax into x power n minus 1. The integration is done explicitly here. You will get again a reduction by 1 n minus 1 minus 1 is n minus 2. And your reduction formula is written over here. Again you can differentiate and check. Now this is a new type of function. Derive the reduction formula for sine power n ax. Then a here, which is not written here, which will be corrected in your other Moodle notes. Now sine power n you take can be written as sine power n minus 1 into sine ax. Again we'll be using integration by parts. Put u equal to sine power n minus 1 and du equal to a into n minus 1 sine n minus 2 into derivative of cosine. Derivative of sine is cosine, and the a comes here. Now dv equal to sine ax dx, and we'll get v equal to minus 1 over a. This minus has to be noted, 1 over a cos ax. Now again use integration by parts. We will get minus 1 over a sine power n minus 1 ax cos ax plus n minus 1 cos square sine n minus 2. Now cosine square can be written as 1 minus sine square. So you will get, now multiply with this one here, you will get sine n minus 2 power in the power and minus n minus 1. This 2 plus n minus 2 will give you sine n. Now we are having sine power n, which was your original integration, which is coming on the left and on the right with minus n minus 1. You add n minus 1 sine power n on both the sides. You will get this n minus 1 plus 1 will be n. Then you divide by n, you will get, this is your final reduction formula. And again, as I have told you, in trigonometric functions, the jump is by 2, and you have to be careful how the a and the n appears in the formula. Again, it can be checked by differentiation. Now derive the reduction formula for cos power n. The procedure is very similar to the sine case, so we will not discuss it in detail. It is cos power n ax, so that a will be corrected here soon. Now let's look at some other new thing. Now derive the reduction formula tan power n ax. Now when if n equal to 1, then we use the substitution u equal to cosine and du by dx equal to minus a sine ax and du equal to minus a sine ax dx. Sine ax dx equal to minus 1 over a du. Now tangent is sine over cosine. Derivative of cosine is sine, so we put u equal to cosine x. Derivative of cosine is minus sine, but that minus is taken care of, so we do not emphasize it on it while speaking about it. But when we sit down to write it, the minus is there, the 1 over a is here, and you will get This is 1 over u into derivative of u, and you'll get 1 over u bracket minus 1 over a du, because sine ax dx is minus 1 over a du. This minus 1 over a will come out, you will get 1 over u. When you integrate 1 over u, you will get ln u, and it is minus 1 over a ln u plus c. And u equal to cosine x. There are different ways to write it using the logarithm properties of the natural logarithm. Will not get into much detail about it. If n equal to 2, use the identity tan square ax equal to secant square ax minus 1. This is your basic triangle identity, and integration of tan square will be secant square, integration of secant square minus 1, integration of secant square is tangent with 1 over a, and integration of 1 is x. So this is your thing, 1 over a tangent ax minus x. When is n is greater and equal to 2, both are allowed, then you use the same idea. We are not going to use integration by parts. You'll write 10 power n as 10 power n minus 2 into 10 power 2 ax, which is tan square ax. Tan square ax is secant square ax minus 1. Now derivative of tangent is secant square, so we can use substitution here, and that minus 1 will contribute to your reduction formula. Now this is it. Write secant square as tangent as u equal to tan x, du by dx equal to a secant square x, because the derivative of tangent is secant square in this step, and du equal to a secant square ax dx, secant square ax dx equal to 1 over a du. So you do this, 10 power n minus 2 secant square will be 1 over a u power n minus 2. When you integrate, you will get n minus 2 plus 1, which is n minus 1. So this will be your integration for this part, and this is your reduction formula. And again, you can check your answer by differentiation. Now same thing will happen secant power n. When n equal to 1, your integration is 1 over a ln absolute value secant ax plus tan ax. When n equal to 2, secant square, you can directly do it as we have done it before, 1 over a tangent ax plus c. When n is greater and equal to, both are allowed, then you use secant power n, you convert to secant power n minus 2 into secant square. Now this is equal to secant square power n minus 2 into 1 plus tan square. Now u equal to secant power n minus 2, we are going to use integration by parts, and du equal to a into n minus 2 secant power n minus 2 into tangent ax dx. dv equal to secant square, v equal to 1 over a tangent ax. Now use the integration formula, you will get 1 over a secant square n minus 2 into tangent minus n minus 2 secant power n minus 2 tangent square. Now this tangent square you will again convert to secant square minus 1, you will get secant power n minus n minus 2 secant power n minus 2. Now secant power n is coming on the left and on the right. Here the coefficient is 1, here the coefficient is n minus 2. You take the n minus 2 this side, it will become 1 plus n minus 2, which is n minus 1, and divide by n minus 1, and this is your algebraic term, you don't have to worry much about it. Divide by n minus 1, you'll get integration of secant power n is 1 over n minus 1a secant power n minus 2ax tan x, plus n minus 2 divided by n minus 1 secant power n minus 2ax. This reduction formula does not work for n equal to 1, and we have seen how to do it for n equal to 1. This is your formula from another chapter, which you have seen. Only for the tangent, we did not use integration by parts. For all other cases, we used integration by parts, and again here this reduction formula does not work for n equal to 1, and for n equal to 1 you have to use integration by substitution, and this is your result. So you have to be careful what we are doing. Just do not use it mechanically. Look at the thing, you cannot divide by 0 in any mathematical situation. So if you have a 0 in the denominator, then think about another technique. So this formula cannot be used when n equal to 1. When n equal to 1, we use this formula. You get minus 1 over a ln cos ax, or an equivalent expression of this type if you wish. Now we have finished all the 8 derivations, and again you can verify the answer by differentiation. Now let's do some problems. Evaluate x power 2 e power 6x using the following reduction formula. The reduction formula is given to you in the question, so do not think about any other techniques which you know. Just note down n equal to 2, a equal to 6. Now look at the integration formula, just note it down and then start putting the values. N equal to 2, a equal to 6. What's the formula? 1 over a x power n e power x. So 1 over 6 x power 2 e power 6x. Minus n by a. N is 2, a is 6. Just write it like that. X power n minus 1. X power 2 minus 1 here inside the integration e power 6x. E power 6x is not going to change at all. Only the outside power will change. 2 minus 1 is 1. This is it. 2 by 6 is 1 by 3. If you want, you can simplify it in the next step. Now you'll get, this is your algebraic term which you can keep copying in all the steps. Now you have this 2 by 6 will become 1 by 3. Now x power 1 e power 6x. Now again apply the reduction formula which is given in the question. You have 1 by a x power n into e power 6x. Now n equal to 1 minus n by a. N is 1, a is 6, minus 1 by 6, x power n minus 1. 1 minus 1 e power 6x. 1 minus 1 is 0. Anything to the power 0 is 1 except x equal to 0. Okay. But that you don't have to worry much in this situation. Now this is your algebraic term. This is your algebraic term. Open the bracket. You will get minus 1 by 3 into 1 by 6 is minus 1 by 18. Now no need to write x power 1. Just write x. Then minus 1 by 3 into minus 1 by 6 is plus 1 by 18 e power 6x. Now e power 6x, you know how to integrate. It is 1 over 6 e power 6x. Now 18 into 6 is 108. You can take 108 as common. Then you'll multiply with 18 here and 6 here and 1 here and put it in a bracket. You'll get 18x square minus 6x plus 1 e power 6x. And this is your last step. You put plus c as the constant of integration. You can again differentiate and check. We'll not go into differentiation details in this video. We have seen it before in other chapters in other classes. Now evaluate x power 3 e power 5x. We are using the same reduction formula as the last question. Here the power is 3 and a equal to 5. Just note down n equal to 3, a equal to 5. If you want to write it down, right. Otherwise, directly put it in the answer. You have x power 3 e power 5x 1 over a. So it is 1 over 5 x power 3 e power 5x. Minus n by a, you will get minus 3 by 5. You will get integral x power 3 minus 1 e power 5x. 3 minus 1 is 2. Now this is your algebraic part. Write it in many steps. Now inside the integral you have x power 2 e power 5x. What's the rule? The rule is x power n with 1 over a x power n e power ax. 1 over 5 x square e power 5x minus n over a minus 2 over 5 integral n minus 1. N is 2 this time. Last time it was 3. Now it has become 2. So 2 minus 1 which is 1 e power 5x. No need to write the step 2 times. I wrote it for your understanding. Now take this, open this bracket, you will get minus 3 by 25 and plus 6 by 25. Nothing is going to cancel here. Now x power 1, now n was before 3, then 2, now it has become 1. We are using a reduction formula. Now again apply the reduction formula from here. It is x power 1 into e power 5x minus n by a. N is 1, 1 over 5, integral 1 minus 1 is 0. The power is 0, which is 1. We do not write the 1. E power 5x is as it is. Integration of e power 5x is 1 over 5 e power 5x. Please use brackets to keep track of these numbers. So your final integration is this. If you want, you can take the 625 common, then 625 by 5 is 125. 625 by 25 is 25. 25 into 3 is 75. Then 625 by 125 is 5. 5 into 6 is 30. And 625 divided by 625 is 1. 1 into 6 is 6. And remember the plus minuses, take e power 5x out common, it looks better and it's easier to use the function when when you factorize it. A factorized function is always better than an unfactorized one. Then again, do your 3-line differentiation. It's very important to check your answer by differentiation. Now problem 3, evaluate ln 5x whole square using the following reduction formula. Do not try any other technique. N equal to 2, a equal to 5. Now look at the formula. It is x bracket power n minus n ln ax whole power n minus 1, and in this bracket you have ln ax. Now your power is 2 and a equal to 5. So just copy. One part is outside the integration. Your algebraic part, just copy it in all the steps. X ln x 5x whole square. This cannot be simplified. Just copy it in all the steps. Then you keep track of the integrations. Integrations are minus n integral ln ax power n minus 1. So n equal to 2 in this question, and it is ln 5x power 2 minus 1. 2 minus 1 is 1. We write it here. Now the power was 2 in the question. Now it has become 1. Apply the reduction formula one more time, and your integral will become power 1 minus 1, which is 0, which is 1. Anything to the power other than 0 is 1. So now you know how to integrate 1. When you integrate 1, you will get x, and there is a 2 sitting outside. So this is your integration completed. Now x is coming in all the terms, so keep x outside, and in the bracket you will get ln 5x whole square minus 2 ln 5x plus 2. The constant of integration is added only in the last step. Integration can be checked by differentiation, and please do it. It will just take 2 or 3 lines to verify your answer. Next, we'll use the same reduction formula with power 3 and a equal to 6. Now start with power 3, it becomes power 2, then it becomes power 1, and then it becomes power 0. So the integration is very similar to the last time, except that last time question you did with 2, now you are doing with 3. If you do it 4 also, it will take 2 extra lines, okay? For one number, it should not take more than 1 or 2 lines. One line is sufficient. Some people need 2 lines to write more details, they can do it. And again, remember to factorize it because x is appearing everywhere and you can do it. Now, evaluate sine square 5x dx using the following reduction formula. See, there are many ways to do this question, but today our focus is on the reduction formulae, so please do not try any other technique. See, I have written a note. There are simpler methods to do this integration. People who know trigonometry will use the double angle identity to do it, but we will not do it in that method in this video today. N equal to 2, a equal to 5. What's the reduction formula? Minus 1 over na sine power n minus 1 into cos power 1. This is the part, algebraic part, which is outside the integration. Just copy it after putting the number. N is 2, a is 5. You'll get 2 into 5 is 10 minus 1 over 10. 2 minus 1 is 1. Do not write that one. Sine 5x into cos 5x. This is your first term. Copy it all the time. Now your second term, which is your integration term, has to be examined more closely. N minus 1 over n, 2 minus 1 divided by 2, which is half. Now sine power n minus 2 is sine power 2 minus 2 in this case. Power 0 means 1, and integration of 1 is x. And this is a half sitting outside, so it will become half x. In the last step, put plus c. You can do some trigonometric manipulations on this, but we will not do it in this chapter. We'll just mechanically follow the reduction formula. And again, you can check the answer by differentiation. Next time we'll take power 3 with the same reduction formula and a equal to 6 and equal to 3. Now when you put the value, your first term is minus 1 over na sine power n minus 1. N minus 1 is 3 minus 1, which is 2. So your first term is minus 1 over 18 sine square cos 6x. Write it several times. Now your second term is your integration term, 3 minus 1 divided by 3, which is 2 by 3. You will do it. And remember, there is a plus in the formula, so just write plus throughout. Now inside the integration, you have n minus 2, which is 3 minus 2, which is 1. Integration of sine is minus cosine with that number 1 over a equal to 6, or you can say a equal to 6, you'll write minus 1 over 6. Now 2 by 3 into minus 1 by 6 is minus 2 by 18 cos 6x. Now you can take the cos 6x common with 1 over 18 common, minus 1 over 18, you can write it as sine square plus 2. Sine square equal to 1 minus cos square, it will become 3 minus cos square. You can do some more trigonometric work on this, but we will not do it. Then the constant of integration is added only after all the algebra is over. After all the integration is over, and you can add it like this. And please check the answer by differentiation. Next, evaluate cos square dx using the following reduction formula. Now n equal to 2, a equal to 9. This is a one line question. Now look at the reduction formula and do it. It is 1 over na. So n equal to 2, a equal to 9. You'll get 1 over 18 cos 9x sin 9x. Now let's look at the integration part. The integration part is n minus 1 over n, which is 2 minus 1 over 2, which is half. Cos power n minus 2. Cos power 2 minus 2 is cos power 0, which is 1. Now integration of 1 is x. So this is your integration. You can do some trigonometry on this, but we do not need it. And remember to add the constant of integration and check your answer by differentiation. Now evaluate cos cube 5x. Last time we did cos square, now it is cos cube. The reduction formula will be the same, obviously. N equal to 3, a equal to 5. Now look at the reduction formula. The outside algebraic term is 1 over na, 1 over 3 into 5, it is 1 over 15. 3 minus 1 is 2, n equal to 3. We get cos square sine 5x, write it in all the steps. Now look at the integration part carefully. It is n minus 1 over n, 3 minus 1 over 3, which is 2 by 3. Do not make any mistakes in these numbers. Sometimes we make a mistake. Inside you have cos power n minus 2, 3 minus 2 is 1, you have cos power 1. Integration of cosine is plus sine over the number 1 over 5 sine 5x. Open the bracket, 2 by 3 into 1 by 5 will give you 2 by 15. I am using so many brackets so that we do not make any mistakes. The brackets can be removed. Now this is your final answer with plus c. We can do some trigonometric manipulations on this. Do not worry about the trigonometry part of it. Your integration stops here. Now check your answer by differentiation. Now we have another type of reduction formula for the question integral x squared sine 4x using the following reduction formula. Now this reduction formula has three terms. Unlike the previous formula, two terms are outside the integration and the third term is your integration term. In all your reduction formulae, you will have an integration term, obviously. Now these two terms you'll copy in all the steps, and this one you will integrate till the integration disappears. Now n equal to 2, a equal to 4. Now the first term is minus 1 over a x power n. So you'll have minus 1 over 4 x square cos 4x. The second term is n over a square x power n minus 1 sin ax. Put n equal to 2, you'll get 2 over 4 square into x power 1 sin 4x. So these two terms will go in all the steps which you are doing. Now let's look at the integration part. N into n minus 1 by a square with the minus outside. 2 into 2 minus 1 divided by 4 square. A equal to 4, n equal to 2. 2 into 2 minus 1 is 2. 2 over 4 square is 2 over 16. Minus 2 over 16 is minus 1 over 8. Now put a bracket for the integration answer. The integration answer is x power 2 minus 2 n minus 2, which is power 0, which is 1, and into sine 4x. Integration of sine 4x is minus 1 over 4 cosine 4x, which is in the bracket, minus 1 over 8 outside. You multiply these two, you'll get plus 1 over 30. Now you can put plus c here. You can take the cosine terms together. It is always good to put cosine outside and the polynomial in a bracket. It helps you to understand the graph and some other parts of the function, properties of the function. Now again check your answer. Spend 2 minutes on differentiation because your answer needs to be verified. Now let's look at evaluate x power 3 sine 8x using the following reduction formula. This type of reduction formula we have seen before. N equal to 3, a equal to 8. The first term is minus 1 over a x power n cos ax. So you'll get minus 1 over 8 x power 3 cos 8x. Your second term is n over a square. So 3 over 8 square is 3 over 64. X power n minus 1. 3 minus 1 is 2. So you'll get x squared sine 8x. Then the third term is n into n minus 1 over a square. So you have 3 into 3 minus 1 over 8 square, which is 3 into 2, 6 divided by 64, which is 3 over 32. Inside the integral, you have x power n minus 2 sine ax. Now you'll get 3 minus 2 is 1, a equal to 8, so it is x sine 8x. Please do not try any technique of integration here. Go back to your integration formula. Now it is minus 1 over 8 x power 1 cos 8x in the bracket plus n o plus the second term n over a square 1 over 8 square into x power n minus 1. 1 minus 1 is 0. You will get it. The third term will become 0 in the bracket. Why? Because it is n equal to 1. 1 minus 1 is 0. So this integration term will not come in the bracket here. When you integrate x power sine 8x using this integration formula, you'll have only these two terms without the integral. So you have to be a little bit careful while doing it. Multiply all these numbers, take them common, you get very big numbers. You can use calculators if you so wish, and then again keep sine and cosine outside and the polynomial inside the bracket. And it will take 4 lines to check your differentiation. Check by differentiation. Now one more question. Evaluate x square cos 5x using the following reduction formula. Again we have 3 terms in the reduction formula, 2 without integration which are algebraic and 1 with integration, n into n minus 1 over a square. N equal to 2, a equal to 5. This question is similar to the last question, except that you have to be little bit careful. Now your integration is x power n minus 2. Now you have the cosine 5x. Please put a bracket here. Integration of cosine is plus sine with 1 over 5. So it is 1 over 5 sine 5x. And again take things common for the sine and the cosine, and this is the way you write it. And check your answer by differentiation. Now let's do this question more carefully. X power 3 cos 7x. The reduction formula is the same. Two terms are without integration. There is only one integration term here, and it is, we'll see what it is. N equal to 3, a equal to 7. You have 1 over a x power n sine ax. First term, so which is 1 over 7 x cube sine 7x. This will continue in all the steps. Then you have n over a square x power n minus 1 cos ax. 3 over 7 square x power 3 minus 1 is x square. So 3 by 49 x square cos 7x will continue. All these a's are equal to 7. I will correct it in the typing. Yes, that will be corrected. And Then your integration term is n into n minus 1 by a square. It is 3 into 3 minus 1 by 7 square, which is 6 by 7 squared, 6 by 49, x power 1 into cos 7x. Now, this integration, you have come down from 3 to 1. Do not try integration by parts here. Use the reduction formula. Except that when you put n equal to 1, the integration will not be there because you'll need only these two terms which are same as your integration by parts, but copy it the reduction formula. It is 1 over a x power n sine ax. So you'll get 1 over 7 x power 1 sine 7x plus n by a square, 1 by 7 square, 1 by 49, x power 1 minus 1 is 0. So we will write x power 0 is 1, x is not equal to 0, and cos ax. So this is it. Now open the brackets, take 2401 common, you will get this huge term, which is it. Two sine terms and two cosine terms. I don't have to read all of them, they are straightforward. Now we have to do one question for the tangent, tan power 4 5x dx. There is no point doing a question for tan square because tan square is easy. You can do it as secant square minus 1. Now n equal to 4, a equal to 5. Now your first term is 1 over n minus 1a, 1 over 4 minus 1 into 5. 4 minus 1 is 3, 3 into 5 is 15, 1 over 15, tan cube 5x. Now 4 minus 1 is 3, so you'll get tan cube. This term will be common throughout, just copy it. The second term is the integration term, tan power n minus 2. There is no n outside the bracket. Now you'll get 4 minus 2, which is 2, tan square. Now again, do not use any other ideas from other chapters, just use the reduction formula. What does the reduction formula says? It is 1 over n minus 1a. So put a bracket, 1 over 2 minus 1 into 5. So 1 into 5 is 5, 1 over 5, tan power 1, 5x. Minus integration of tan power n minus 2. 2 minus 2 is 0. So you'll get 1, integration of 1 is x. So inside the bracket you have this minus into this minus is plus. You'll have tan cube over 15, tan 5x over 5 plus x plus c. You take 1 over 15 common, you'll get tan cube minus 3 tan plus 15x plus c. And inside the tangent you'll have 5x. That is not going to change. Then you can check your answer by differentiation and with some algebra. And you'll need some trigonometric identities to execute the differentiation completely. Now the last question in this topic is integration of secant power 4 7x dx using the following reduction formula. If the reduction formula is given, you are jumping by power 2, n is going to n minus 2, which is good. Your integration will be faster. So n equal to 4, a equal to 7. Your first term is 1 over n minus 1a secant power n minus 2 tangent. Now put a equal to 7, 4 minus 1 into 7 is 3 into 7, which is 21, 1 over 21 secant squared 7x 7 tan x plus now the integration term n minus 2 over n minus 1, 4 minus 2 divided by 4 minus 1 is 2 divided by 3. Now the inside the integration is n minus 2, it is secant square 7x. Now this secant square, again you are going to use the reduction formula. Don't try any other techniques. This 2 by 3 is outside the integral, so put it outside the bracket. Now again put the reduction formula. So n equal to 2, 1 over n minus 1 into a, 2 minus 1 is 1, 1 into 7 is 7. So inside the integral you will get 1 over 7 and 2 by 3 into 1 by 7 is 2 by 21. Secant power 2 minus 2 is secant power 0. So we'll write 1 into tangent power 7x plus 0. Because when you put n equal to 2, the integration term will disappear here. So we write plus 0 here. Now you'll have 2 over 21 plus into tan 7x and remember the constant of integration. You can take 21 common, you can take tangent common, you'll get 2 plus secant square, which is equal to 3 plus tan square. You can do it like that. You can convert the tangent to secant square or secant square to tangent. Or if you want, you can keep both. but that is normally not done. So this is it. So in this chapter, let me tell you once again, the reduction formula will help you to go from big power to small power, and you do not need any other formula. You use the same reduction formula again and again till you get a power like 1 or 0, and that completes your answer. Thank you. See you soon in the class, inshallah.